So if you go to a doctor for depression or anxiety, they're going to have their first line drugs. So for anxiety, it might be a serotonin drug, it might be a benzodiazepine that they give you. So they're assuming that the cause is low serotonin or low, or problems with overactive excitement and or low GABA. But the problem with that is there's lots of contributing factors. You can have anxiety because of having dysregulation of your cortisol. You can have problems with serotonin, but it might be that you're not making enough serotonin. So giving something to recycle serotonin isn't the answer. Giving things that support the synthesis of serotonin is the answer. But it also might be that there's cofactors that relate to making serotonin or making GABA that are missing. And so what we do is we look at all these different factors from a genetic standpoint, and they're all in the literature is the really exciting thing.
Welcome to the Mind Health 360 show. I'm Kirkland Newman, and if you, your loved ones, or clients suffer from mental health issues such as depression, anxiety, insomnia, poor memory, poor attention, mood swings, exhaustion, etc., I interview the leading integrative mental health practitioners from around the world to help you understand the root causes of these symptoms, many of which may surprise you, and suggest solutions to help you heal. If you like this interview, please do subscribe and forward to others who might find it helpful. If you want further information, please go to www.mindhealth360.com or find us on social media. So Dr. Sharon Hausman-Cohen, welcome to the Mind Health 360 show. I'm thrilled to have you. You're one of the, pioneers in genomics and how it's really changing medicine and mental health, which is what we're interested in. Okay, so Dr. Sharon Hausman-Cohen is the Chief Medical Officer and co-founder of IntellxxDNA. You've been in the field of integrative medicine for over 25 years and are the co-author of many publications and a textbook chapter related to using genomics to improve outcomes in cognitive decline and autism in particular. But we know that you cover so much more than that. You're very proud that IntellxDNA is being used in studies done by Dr. Dale Bredesen and his team and other groups studying complex illness, as well as by well-respected functional medicine-trained physicians across the country. You and your co-founder developed IntellxDNA as an answer to an unmet need in the medical community, the need for an accurate, evidence-based genomics tool geared to helping physicians practice true root cause medicine, whether the patient has cardiometabolic disease, brain concerns, or medical mysteries. You received both your master's degrees and medical degree from Harvard Medical School, and in addition to supervising the research for IntellxDNA, you practice at Resilient Health in Austin, Texas. For access to your publications, podcasts, and videos, see www.intellxdna.com, spelled with 2 X's. So Dr. Sharon Hausman-Cohen, welcome. So tell us a little bit about how you created this company and why you created it.
Yeah, that's a good question because I wasn't bored. I created, along with my co-founder, we created the company because we're actually looking for a tool to help our practice, to help our patients with cognitive decline, our patients with mysteries, be able to use their own genomics in their health. And there wasn't a tool out there. So people would come to us, bringing us their 23andMe or whatever they've done and say, can you help me prevent cognitive decline? Can you help me with my depression? Can you help me because I have a family history of Parkinson's? Or whatever the situation was. And it might even be something as simple as heart disease or diabetes, because they knew I had a background. I had a pretty strong background in genetics. And so I thought, oh, sure, there must be a tool out there for helping me to interpret it. Because, of course, there are 3 billion base pairs and over 1 million SNPs. So it's not something you can just memorize and keep in your brain. And there was no tool that was geared at physicians, people who wanted to not just know kind of genomics for fun or even nutrigenomics, but understand the root cause, what was causing somebody's depression or cognitive decline. And it also correlated. I'd met Dr. Bredesen and when we were working on this, and he was doing the same thing in terms of going, we've got to get at the root cause. And so I was like, wow, we can add that on to the genomics and use that same concept and get at the root cause from a genomic standpoint. So we did it because we wanted to change medicine.
So that's fascinating, and well done for that. So there are two questions that come up for me with that. One of them is, so you mentioned delbredazine and obviously the functional medicine approach, which is a lot of blood test and urine test and stool tests, et cetera, looking at the biochemistry. How does the genomics aspect fit in with that? And presumably it's complementary, but how do you work with the two together? Do you use one to inform the other?
Absolutely. So the reason that doctors are using all this different testing is they're trying to look for the root cause. And so once a doctor is trained on genomics, it is very frequently the jumping off point, because you can then go, oh my gosh, this person has horrible detox pathways. Could what's going on for them be caused by mercury, pesticides, glyphosates? And there's different detox pathways that contribute to different kinds of toxicants and toxins. Or this person has all of these nutritional related SNPs that relate not only to their ability to absorb this nutrient, but carry it to the brain. Maybe I need to try this. Maybe I do want to check further testing, or maybe I just want to jump off based on the genomics. Or somebody, again, might have SNPs that make them have higher risk for neuroborreliosis, brain Lyme disease. And then it gets you just thinking. So genomics can help you think. Really, once doctors start using it, it dramatically cuts down on testing. Mm. We have an autism physician in California, and she has done many, many, many dozens of these reports. And when I was speaking with her about it, she uses it first line. She was saying that it's dramatically cut down how many other tests she has to use. And with children, it's great because it's a cheek swab. And so that's been a real benefit. So I think that, yes, we use a lot of testing in functional medicine, and there's some things it's not going to be able to replace. It's not going to be able to replace organic acids or stool testing, because that doesn't relate to your DNA in the way that we have access to right now. But if you think about psychiatry, what blood tests are there that can really tell you what's causing someone's anxiety or ADHD or depression? There's like nothing.
Exactly. And so can you explain exactly in those situations, like how does your tool help identify the potential for depression, anxiety, ADHD?
Absolutely. So let's take the topic of anxiety, because I think that that's a easy one. Stress, and I don't like to label things, so we call it the stress and anxiety panel. So if you go to a doctor for depression or anxiety, they're going to have their first line drugs. So for anxiety, it might be a serotonin drug. It might be a benzodiazepine that they give you. So they're assuming that the cause is low serotonin or low, or problems with overactive excitement and or low GABA. But the problem with that is there's lots of contributing factors. You can have anxiety because of having dysregulation of your cortisol. You can have problems with serotonin, but it might be that you're not making enough serotonin. So giving something to recycle serotonin isn't the answer. Giving things that support the synthesis of serotonin is the answer. But it also might be that there's cofactors that relate to making serotonin or making GABA that are missing. And so what we do is we look at all these different factors from a genetic standpoint, and they're all in the literature is the really exciting thing. There's even for anxiety, SNPs that relate to how your brain processes thyroid hormone and converts it from T4 to T3, and sugar. So I had a really fun case of a young woman who came to me with ADHD and anxiety, and she was drinking a big Coke on her way to class to keep herself awake because she was a college student and had a 8 a.m. class. And she had a gene that gave her high risk of anxiety with sugar, and just switching her to tea in the morning. So she still got her caffeine, or told her if she really wants Coke, use the regular one, but, use the sugar-free Coke if she wants that as her caffeine source. And that made a huge difference on her anxiety. And she could have easily gone to someone and been medicated for something that a lifestyle intervention would have helped with.
And I think that's really interesting because, our current medications, for instance, for depression tend to be SSRIs, which just increase the amount of serotonin that's sort of up there in the synapse. And so, but, the things that you mentioned are so much more multifactorial. There's so many things that could contribute to low serotonin, whether it's, the cofactors and so the beauty of what you do, I think, is you look at all these different areas that impact serotonin production or uptake or reuptake or whatever it is. And you really get a much more sophisticated picture than just giving an SSRI.
Yeah, I think that is absolutely true. And that is an important part of it. But I think it's also that we can go so much broader, because we talked a little bit, I mentioned about nutrients. Everybody knows that inflammation is a big factor in chronic disease, but sometimes people don't realize how important that could be, for example, in mental health. And so we also can look at the different kinds of inflammation. And there's a number of them that can cross the blood-brain barrier, TNF alpha and IL-6 and CCL2. And just like if you have an infection, you can't treat it if you don't know what kind of infection. You're not going to be able to accurately treat brain inflammation unless you know what kind of brain inflammation and what supplements address that kind of inflammation and cross the blood-brain barrier, and also have evidence for things like depression or whatever you're treating. And so that's what we do, is we bring the link to the doctor of bring that information so that they have kind of a map. Here's information about my patient about all the root causes, and chronic disease is never one root cause. There's no gene for depression. There's no gene for anxiety or ADHD. It's a mixture of a little bit of this and a little bit of that. But then we say, how does it work and what can you do about it? And also, how do things like detox, inflammation, gut, and nutrients play into it, as well as all of the different genes that affect serotonin and neurotransmitters and brain connectivity and much more of the very specific to to a disease.
So interesting. So would you say that the USP, sort of your unique selling proposition of IntellxDNA, is the fact that not only do you identify all these potential root causes of these mental health issues or physical health issues, but also you suggest solutions, and you research-based, you spend a huge amount of time researching, and all this is very evidence-based. All the different interventions, whether they're lifestyle or supplements or nutritional interventions, that can actually help address the genomic SNP, essentially, that might be at the root cause of these manifestations. Is that the USP?
Yes, and I had not heard that term before. That's a great term. I always called it the secret sauce, but that's probably USP is probably a better term. So yes, that's exactly it. The thing that we do differently is we are a different category. We're what's called a clinical decision support tool, which means that what our goal is to take all that wonderful research that's out in the literature about genomics, what genes are associated with mental health disease states, then also take the research which is done maybe in a separate lab or separate places as to how does that gene variant work. So so just for users who aren't fully versed in genomics, you can have a gene, and think of it for the people who are a little older, kind of like those ribbon candies like the candies, or if you took like a rope and you kind of folded it or tangled it up, that's what a gene looks like, though, kind of a massive rope tangled up. And one gene will interact with maybe 10 or up to 100 other genes. And so if you make a one-letter change, you just make a notch on the rope in one position and change something about it, depending on where that changes, it can have different effects. So vitamin D receptors can be involved in autism. They can be involved in cognitive decline. They can be involved in autoimmune disease. But you can't just go, oh, this gene's called VDR. It depends what position. So we take the research about what position affects what disease state, how that variant works. And then we say, well, what can we do to overcome it using diet, lifestyle, supplements, and medications? And every sentence we put a reference on so that doctors and clinicians that are using it can kind of follow. And then we also have an educational section so that if the doctor has not used a particular supplement, they can learn more about it, the safety, the dosing. So we're kind of like a textbook of integrative or functional medicine mixed in with a precision map to your patient. So the references are there if you need the help, but the map gets you going so that you can go, okay, there's 100 things I can use to treat someone's depression. There's studies, or ADHD, there's studies for zinc, there's studies, for pycnogenol, there's studies for all kinds of, Bacopa. How do you decide what you're going to start with for that patient? And so this is how we help our clinicians.
And so it's really bringing precision medicine to patients essentially by this tool. Is basically it's super precise and it's personalized medicine. I mean, we talk about precision medicine and personalized medicine, but you're actually enabling this to happen.
Right. And I think that we're taking personalized medicine down to the DNA level. So I think that before in functional medicine, because functional medicine started before we really had access to tools like IntellxDNA, they had their wonderful map of what were the triggers, what happened in the history, and they were using history and labs. But if you think about the blood tests or stool tests, those are getting one set of information, but a blood test is almost like a blood biopsy. You can see what's going on in the blood, but because of the blood-brain barrier, your DNA is not going to, what's going on in the brain is not going to necessarily be reflected in the blood. You can have inflammation in the brain that is 40 times higher than in the blood, and it can have to do with specific gene variants. Or you can have a B12 level that's normal in the blood, but abnormal in the brain. And again, specific variants. And there's no test for that because we can't test across the blood-brain barrier. So genomics adds to mental health and all brain conditions, autism, cognitive decline, huge advantages because you can learn a lot about the brain without doing invasive testing because it's just a cheek swab.
Would you then say that genetic sort of genomics and what you do, I know you do other panels as well, so you do cardiometabolic, et cetera, but would you say it's best suited to mental health simply because of what you're saying, which is that, the brain is such a hard organ to access?
Well, I think that it is uniquely beneficial in a way that that is even stronger than cardiometabolic is still great for because there's so many causes of heart disease and diabetes, and it absolutely is very helpful at adding precision. But there are some really good tools, some very specific kinds of scans and other tools that have been developed in cardiometabolic disease. So I think that the advantage to brain science is we had no tools. If you think about, what information a psychiatrist gets before deciding what to prescribe, very little. And they thought that pharmacogenomics was going to be their answer. But if you think about pharmacogenomics, that's talking about, does this person metabolize this drug well? So if somebody is a rapid metabolizer of a drug, they might need more. If somebody is a slow metabolizer of a drug, they might need less. But what if the cause of their depression is not because they're low on serotonin, but they're low on a cofactor like tetrahydrobiopterin? That's a fancy one, but it's actually important if it's you, or it's 4% of the population. It's a big factor for their depression. Or what if it's because they can't make enough folate their folate receptors are abnormal. So even if they give a methylfolate, it can't get into the brain. So there's so many different factors. And in mental health, we have now added a tool that's the equivalent of 100 different tests that are specific to the brain. So I think that's the big advantage. I also have a strong background in neuroscience. And so that was probably part of what drove it, is it was a big interest of mine. But it is, I think, really important to the healthcare space.
It's so interesting. And, I mean, the holy grail, of course, has always been finding the biomarker for depression or the biomarker for anxiety. And there's been a lot of effort around that. But, as we know, there'll never be one biomarker. There's a whole conjunction of these biomarkers. And I often argue with people, who say there are no biomarkers and we'll never find them. And I'm saying, well, there are a number of different biomarkers, but they might manifest differently. Would you say that what you do, in some sense, really replaces that need for the holy grail of the biomarker, in the sense that it's sort of the closest thing we have potentially to biomarkers?
Absolutely. I think that it's better than a biomarker because, again, of the blood-brain barrier. So there are studies showing that interleukin 6, which is a kind of inflammation that crosses the blood-brain barrier, that interleukin 6 levels are associated with depression and autism. There are studies showing that TNF alpha can be associated with a variety of causes of depression. That's one of the reasons that people who get rheumatoid arthritis have more depression. There are all kinds of studies showing that low different nutrients can be associated with depression, but you can't get at these different things, and you can't get at the receptors. So you could say, oh, low GABA must be associated with anxiety, but it actually, from a genetic standpoint, looks like it's more dysfunctional GABA receptors. And so how are you going to be able to get at the receptors in the brain? You would have to do a brain biopsy, which most people frown upon having done. And so I think that everything's in the literature. These are all different causes, but it makes sense that chronic diseases that are so common are not due to one gene. Because if depression was all caused because of low serotonin, then you would think that giving somebody, well, actually, the serotonin medicines don't work by giving you serotonin. They work by recycling the serotonin you have. So if depression was caused by inability to recycle serotonin, then the SSRIs would work for everyone. And there are some people who don't recycle serotonin well, but there's also a lot of people who don't make enough serotonin, or who make too much cortisol, or who make too much glutamate. And so again, it makes so much sense because we are so different, and not every drug works for the same drug won't work for everyone with the same diagnosis, that diagnosis is not about one gene. And that's just the way chronic disease is.
It is, absolutely. And I mean, there's been a huge increase in complex chronic illness, as we all know. And do you think so? So in some ways, all these diseases are very multifactorial. Whether it's depression or ADHD or autism or cognitive decline, all these involve a lot of different pathways, a lot of different mechanisms. And one of the things, one of the challenges that we have, and I think, that's been such a challenge in terms of conventional treatment, is that there is not one pill for an ill. And so you have to look at all the factors that are impacting these, our metabolism, or our, brain metabolism, or our neurotransmitters or hormones, et cetera. And I think what's really interesting about your approach is that you do look at all these different factors. But given the rise of complex illness, and I think there are a few questions that I have about this. One, your type of medicine and your genomic research is so much more relevant to complex chronic illness. And given the rise, it's almost like there's this perfect storm coming, where there's just this huge need for a more personalized precision approach. Why do you think, and I have so many questions in this one question, but why do you think there is such a rise of chronic complex illness? And how are you guys best suited to really address this?
I love that question, because we are being used by functional and integrated medicine doctors and other doctors that just want to be trained on this across the country, with chronic illness being one area, but complex illness being another. And the things that I'm seeing that I think are really on the rise are things that relate to oxidative stress, things that relate to detox pathways, things that relate to gut permeability. And the reason for the rise is our world has changed. So when you think about the fact that both mold and gluten and glyphosates, well, so gluten wasn't a problem 30 years ago, how many people did you know that were gluten intolerant compared to now? It's like such a small amount. But when you combine it with all these things in the environment, so for example, glyphosates, which is Roundup, which didn't really get into our food supply until the 70s, but then the levels went up by many hundredfold after the 90s. And again, in the 2000s, the amount that you're allowed to have on food has dramatically increased and the amount being used. Well, glyphosates creates gut permeability issues. It affects the tight junctions. It's going to affect the tight junctions more on people who either have detox problems, removing the glyphosate, or on people who have problems with their myosin SNPs that affect the tight junctions. But when you then get more permeability, then instead of having your normal ability to not let food that is big molecules cross the blood-gut barrier and only have kind of the amino acids, the carbonic acids, like the very breakdown products cross the blood-gut barrier, you now trigger the immune system. So autoimmune disease is a huge, huge issue for complex illness. Mold can trigger complex illness because of the same. It also creates autoimmune. It does something called molecular mimicry. But again, why is mold more of a problem? Well, part of it's how our buildings are being built nowadays, with air conditioners being one of the big causes of mold, because you get air conditioner failure and condensation. And then you use paper instead of having stone buildings. You use basically, drywall as a form of paper, which gets moldy. And so part of its environment. And then why are some people more affected by mold compared to others? That's the genomics. I've had families where two members of the family are incredibly sick. I mean, we have, a child that is having bipolar-like symptoms or mania symptoms, and a mother that can't think and has horrible brain fog and just really can't function. And the dad might be like, I don't understand what's wrong with this. And it's then you look at their genomics, and one of them has all these different mitochondrial problems and inflammatory problems and microglia, which are kind of brain garbage collectors. So I think that the rise of chronic disease, sorry, I'm not very good at giving short answers.
No, that's great. I love it.
The rise of chronic complex illness is because we're having collisions between the environment and our genomics and what we're doing to the environment. We should not have been adding, obviously, chemicals without understanding the effects on the body, many of them which can be toxic. Changes in our building, changes in air pollution. And we've had, again, in our genomics, we do extensive detox that relates to air pollution, pesticides, mercury, other chemicals, glyphosates, arsenic, on and on and on, and then help people realize. And, again, these things are important because they make you feel sick, but many of them can contribute to cancer-related illness and again, even skin-related illness, but also brain illness, because many of them can cross the blood-brain barrier.
And tell me, because one of the conjectures of a lot of these big thinkers and even spiritual leaders is that, one of the crises that we're facing, the biggest crisis in our humanity at the moment, is that our capacity to adapt to our environments is slower than the change in our environment. So in the last, 100 years, we've brought about so much change, both medically, technologically, environmentally, in every single way, that our biology can't keep up with that. And so if you look at the sort of genetic and the genomic argument, I mean, is it possible that in another 100,000 years, our genetics would have adapted to these changes? So the processed foods and the increased chemical load, is this a disconnect between our biological sort of genetic makeup with our environment, only in the sense that it's outstripped our ability to keep up and to adapt physiologically?
I think that, yes, we're not able to adapt physiologically, but I don't think we're going to outsmart this by having our genetics change. I think we're going to have to start going back to the roots of understanding what's causing it and say, wait a second, is it worth it to increase our crop size and then expose our children to glyphosates now that we understand how glyphosates affect the blood-gut barrier and that it's a huge contributing factor to chronic diseases, to mental health diseases, to gut diseases, to autism, et cetera? Once we know that something like that happens, I think that we have to change it with policy. Yeah. Now, we're also going to be fighting the fact that in our world, there are other animals and organisms that can adapt more quickly. One of the reasons that Lyme is becoming more prevalent, because again, how many people do you know that had chronic Lyme disease 30 years ago compared to now? Well, again, a small fraction, because we're not getting as deep of freezes. I mean, it's going to be 70 today in here in Texas.
Lucky you.
Which is pretty warm. I know. Well, I don't remember what that is in Celsius for your UK people, but it's going to be pretty warm here later today. And it's winter, it's February. And so the ticks that carry these different tick-borne illness are not dying out during the winters. And so they're being able to kind of migrate across the world and change and evolve because they evolve a lot faster than we do. So I don't believe that we should wait for us to evolve. I think that we should go, what's going on? Let's understand it and say, oh, wow, if 10% of the population have a very difficult time clearing these kinds of air pollutants, and it's contributing to asthma and chronic depression and ADHD. Some of the genes that relate to pollution also relate to ADHD, which makes sense. Then we can say, can we as a country and as a world say, let's change our standards and not let all these things be emitted into our atmosphere? And I think we are seeing some of that. We're seeing more electric vehicles. And so I feel like being open-minded about just because we didn't think that coal used to be dangerous doesn't mean we want to keep using the same things in the same ways. We need to kind of think about the effects on our world and how those effects affect people.
Yeah, and how and contributing this huge health crisis. And then dialing back a little bit, and I probably should have done this to start with, for our listeners who, it's a wide range of people. Some will know exactly what the difference between genetics, epigenetics, and the genome, and others might not. Could you just very quickly explain, the relationship between genetics, epigenetics, and genomics?
Absolutely. So genetics is the science of heredity. So anything that is an inherited disease, that's a genetic disease. And because you have genes from both your mom and dad, genetic illnesses can be either dominant or recessive. So something like cystic fibrosis or Tay-Sachs or sickle cell, if you get those genes, 2 copies on most of those things from your parents, 1 from each, then you would get that disease. But when you talk about genomics, that's that study of small changes in the DNA that do not cause disease, but are contributing to disease. So there are some SNPs, which is a single letter change. It stands for a single nucleotide polymorphism that cause what are considered genetic diseases. But most of those changes are very minor. The difference between brown eyes and blue eyes, curly hair and straight hair, those are genomic, not, type little small changes can do them, and they're not disease causing. And there's actually mixtures, of things. So when you're talking again about depression, anxiety, cognitive decline, autism, PANDAS, PANS, all these kinds of things, addiction, there's not one gene that causes addiction. But if you have genes that make you have higher glutamate, which is kind of makes the brain excited, and then you want to kind of calm it down naturally, so you look for substances, that is one contributing factor. But there may be other factors, like you might have higher cortisol, there might be dysregulation in nicotine genes, and all kinds of different things. And so genomics is the science of lots of little changes that together, interacting with environment and diet, lifestyle, and each other, contribute to disease. That brings us to epigenetics. And the fun thing about epigenetics is this term was coined, can't remember whether it was in the 40s or the 50s by a scientist. So it's been around since before we sequenced the human genome. And it was the concept that we could do things that overlay or on top of our genetics can affect our genetics. And so anything that can modulate your gene is an epigenetic modification. So BDNF, which is a growth factor, is really important. If you don't convert your BDNF from the kind of storage form to the active form, it can give you 150 times the risk of Alzheimer's and 150 times the risk of depression. Mm-hmm. And yet you can have an epigenetic change for that, be exercise, because exercise forces that change. So supplements, diet, exercise, medications can affect the expression of your DNA, because it can turn on and off genes, but it can also affect how genes are processed. But also bad things in the atmosphere and in the world can affect your DNA. So BPA, which is from plastic bottles that I think that you guys aren't allowed to have in England anymore, but we still have in the United States some BPA. And that can affect the obesity genes. Mm-hmm. So there's lots of really cool information out there. And what we do is we take all of that together. We don't look at pathogenic disease-causing genes. So we're not going to give you a report on Tay-Sachs or sickle cell or cystic fibrosis. We look at these genes that have little changes that can be modified by diet, lifestyle, supplements, medications, and how and why.
That's so fascinating. And so to sort of drill down, like, how do you actually do this? So if somebody comes to you and says, I'm incredibly depressed and incredibly anxious, how would you then help them look at what the contributing factors are and then how they can address that?
That's a good question. So we don't just look at SNPs that are associated with anxiety, because in the literature, somebody might have done a study on a gene and said, okay, this gene is found in 2 copies in 4% of the population, and we noticed it's more common in depressed patients. But people can't always describe between anxiety and depression and different mood symptoms. We don't fit into neat little boxes. So when somebody wants to do their genomics for any mental health concern, we do a whole report that consists of about 22 different panels. And we look at everything from the foundations of functional medicine, meaning gut, things that contribute to histamine intolerance and gluten intolerance and lactose intolerance, to extensive inflammation pathways, more than 10 different types of inflammation, to things that looked at all these different detox pathways, all these different nutrients, because as we said, zinc and magnesium and vitamin C and vitamin D, they're all really important for making those brain chemicals. And then we look at the gene variants that in the literature have been associated with all these disease states. So we scan like 500 different gene variants, but then we create what we call our hotspot report to help the clinician go, okay, nobody wants to start with addressing a ton of different things or to look through 500 variants. Here's the top 20 essentially, or here's the ones that are found in them that are not in too many people. And here's, so that you don't have to go and start becoming a PhD or a researcher, here's links to the literature as to how it works. But we also then say, this is how this gene works. Here's how we think the potential interventions you can modulate this gene, and here's why we think that with the references. So we map it out for them. So we take a lot of complex data that's a very wide funnel and make it narrow so that you can start with, here's the top 5 or 6 things that we think might help you with regards to diet, lifestyle, supplements. Most of our clinicians don't want to start with medicines because that's why people are coming to them. It's like, let's address the root causes and see if they get well. And then if that's not enough, we can go back and dig deeper. But generally, we're getting really great results because we're able to help these clinicians find some of the root causes, which also is really validating to the patient. It's nice for them to go, okay, it's not it's not my fault that I had depression. I have 180 times the risk of it compared to somebody who doesn't have this gene, but here's how I can address it. So it can be very helpful and validating.
I mean, that's just fantastic. And for instance, okay, another thing, let's take the example of a young person who has ADHD, for instance, and So one of them might be on meds, one of them might not want to be on meds. So I was listening to one of your podcasts, and one of the very worrying things that you were mentioning was that methylphenidate, which is one of the ADHD meds, can increase the risk of early onset Parkinson's by sort of burning out the dopamine neurons. And I found that quite worrying. My son is on methylphenidate. And so, and then my other son, who also has ADHD, is not on any meds yet, So how would you use your tool to then say, okay, this kid actually doesn't really need to be on drugs, and there's so many other things that he can do, and given his sort of genetic SNPs, these might be the causes of his ADHD. Is that something that you could do?
Absolutely. So with ADHD, we kind of have different sections or categories. And the first category is some of these children have genes that contribute to their brain connectivity. Now, if you catch a child while they're still in the ages of brain connectivity development, which is pretty old for children, you're going up to age, it's going to work better if you have someone that's 7 or 8 or 10 compared to someone who's 18, but our brains are still connecting for quite a while. You can use things like acetylcholine to increase brain connectivity. You can use different kinds of neurofeedback or neural stimulation. And again, it depends on if that's your issue. You can also, there are some genes. There's one that relates to connectivity called contactin, or it's kind of like catnap, the way it's spelled. And it relates to connectivity, but in the auditory processing center. And so if you can't auditory process in the way that we in the 21st century train our children, you're going to have problems in school, because we expect them to sit in a classroom and learn from their teacher, as opposed to going out and doing internships. I mean, 100 years ago, if someone wanted to become, anything, if they wanted to work on a car or things like that, there was a lot more, there weren't cars 100 years at that point, but we used to teach our children their trades. We would have a little bit of the day in school, and then they would go and they would be essentially learning their trade, whether it's working with the local healer or working with the local farmer. They would be working part of the day. But now we have children in school all day. So if you have someone who can't auditory process, they get labeled with ADHD. But if you could instead improve that auditory processing pathway, which partially is improved with oxytocin, partially improved with vitamins A and D, and then there's a few other things that can improve them as well, that makes more sense. But you can do that with food. You can do that with oxytocin, can be increased with probiotics. It could be increased with a nasal spray. So we educate and give choices. And then there's the SNPs that are the classic ADHD pathways that relate to dopamine dysregulation. And some of them respond really well to medicines and some don't. So we also give some of the genomics as to who is more likely to respond. If your issue is that you don't make enough dopamine and norepinephrine, then there are many cases that the medicines for ADHD, like the stimulants, might be beneficial, although there are natural things that can affect that pathway as well. But if your problem is that you can't convert dopamine to norepinephrine, there's going to be other things that are going to be more helpful for that. And even if you do have a child who needs stimulants, if they're, for example, deficient on vitamin D, or the ability to synthesize vitamin D or absorb it, or the ability to absorb zinc, correcting those things can make a big difference. There was a study showing that even if you don't know someone's genetics, giving zinc can decrease the dosing of ADHD meds by 25%. So we help doctors also be aware of what's in the literature, but also what might benefit that particular child. Because again, you really have to, with children, say, okay, to the parents, here's the 2 or 3 things I want you to start from supplements. Here's the 2 or 3 things from lifestyle. You can't start tons of things at once.
With all of it. And it occurs to me while you were talking, because of course, Dr. Greenblatt does a lot with ADHD, and, his book Finally Focused, and he gives a whole list of sort of supplements and lifestyle interventions. And I guess the question is, one, it's sometimes unrealistic, especially with young people, to ask them to do all these supplements and the lifestyle interventions. But my second question is also, if you did sort of do, for instance, the traditional, okay, give more magnesium, give more omega-3, give more lithium, etc., are there any contraindications based on your genomics where it actually might backfire and where really it's important to have this precision approach, personalized approach?
Well, I think that depends on what you're talking about. I don't think that magnesium is going to be harmful at the doses that people are trying. But actually, when you start to learn more, you kind of have to know what kind of magnesium. So magnesium threonate crosses the blood-brain barrier, and we also help with that. We in our interventions, we specifically list how things work, but also which forms cross the blood-brain barrier. So I think it's fine to try, but if you were to look at our ADHD pathway, you would see that there's SNPs that respond to theanine and SNPs that respond to NAC and SNPs that respond to magnesium threonate and SNPs that respond threonate and SNPs that respond to acetylcholine and B6 and and on and on and on. And so I think it's more the issue of and what do you start with? I mean, because then there's a whole nother group of people that might instead need a completely different thing. They might need ashwagandha or B12. And so I think that it's more about not so much that over the counter dosing of lithium or over the counter dose of magnesium is toxic, but you start to have the child have so many things and then you don't know what's working. And so if you can start with genomics and have a smaller regimen that actually works well, we don't make our children feel like they're broken. And if somebody's needing 10 or 15 things to treat their ADHD, then that, even though it may not be a medicine, that child still can be like, well, what's wrong with me? My friends don't have to take all this.
Totally. That's exactly right. And then just a couple more questions. I mean, I have so many, but I don't want to take too long. But one of them is about trauma and ACEs. So there's a lot at the moment in mental health and the mental health world about trauma, trauma treatment, and the interaction between trauma and how it essentially dysregulates the nervous system and then primes you for a greater stress response or greater susceptibility to mold or to Lyme later in life, for instance. Do you look at this interaction on a genomic level? And if so, what has been your insights?
Yeah, so we do. So that's been really fascinating to me. As we've done the research, we all know from as physicians that there are traumatic factors that can make someone more prone to depression, but they've linked that to specific genes and saying that this person will have increased risk of anxiety or PTSD, particularly if they experience early life trauma. And so that's been fascinating to me. And so I think that part of it is because, again, the trauma can affect the HPA, the cortisol axis. It can affect the development of the brain and so many different areas. So we don't have yet specific, like we don't have a trauma pathway for the brain. We're working on traumatic brain injury, but not a trauma. But I do think that we do touch upon how trauma can interact as one of those epigenetic factors to give you a higher risk. So there's a gene that can relate to panic, and it's going to depend on, you might be perfectly calm if there's nothing bad going on in your life, but you have an overactive orexin pathway. And just for people who have not heard of orexin, because it's a pretty new hormone, it's a brain hormone that's kind of the opposite of melatonin. It makes you feel more awake. And if you have dysregulation of that pathway where you release 10 times more orexin, when something happens that makes you feel kind of triggers your, we're supposed to be awake when something bad happens. We're not supposed to be asleep when a tiger's attacking us. But if you have an overactive orexin pathway, when something triggers you like trauma, you're going to get a lot bigger anxiety response. Does that make sense? So there's a lot of genes that do interact.
Totally makes sense. And I guess I sort of look at trauma, psychological trauma is essentially the same or similar to physiological stressors. So whether you're talking about a toxin or a pathogen or a traumatic event, presumably the body recognizes these as stressors, which then dysregulate the neuroendocrine system and possibly in similar ways, whether they're psychological or physiological.
Yes. And I think that the point of what trauma you have, whether you have a trauma of being bit by a tick, being exposed to mold, being yelled at in a way that makes a child feel unsafe, physically threatened, that gets your cortisol pathways going, what genes you have is going to affect that, because there are people there are people that pollens and allergens are traumatic because they have overactive histamine and mast cell pathways, and that even infections will then trigger that histamine, which makes you feel more awake. And then there are people where they're, more overactive cortisol pathways. And so you're absolutely right. The trauma affects your genetics, but what kind of trauma is just like saying, well, what kind of infection, what kind of inflammation? So that's a really interesting way of thinking about it.
It's interesting. And also the fact that, with the sort of body keeps the score, and,
the great book.
the great book, The Body Keeps the Score. It's all about, not necessarily the traumatic event itself, but how it interacts with your physiology, which is unique and completely personal to each individual. And so trauma is not actually the event. It's the way your body has reacted to that event. And presumably that has a very strong genomic component.
Absolutely. Yeah. And I think that, they always say on a general level, when you're experiencing a trauma, you get a certain set of neurotransmitters and brain chemicals released. But when you even think about that trauma that occurred in the past, you can get some of those same memory responses and same chemicals released. So if you already have an overactive cortisol pathway, or an overall, so there's some people who bind their adrenaline 30 times more tightly. Well, if you bind your adrenaline 30 times more tightly, then when you start to get kind of excited or worried, or you think about something that caused that high adrenaline state before, you're going to have a bigger response. So I do think when you're talking about trauma keeps the score, some people can brush things off. They get, COMT is a really well-known gene that is like, I call COMT and MTHFR the pop genes, and because they've been talked about for a long time. But with COMT people, that they talk about warrior and warrior, but really what it is how long does it take you to break down your adrenaline? Mm-hmm. So the people who have 2 copies of what they call the MET, the variant in COMT, which is almost 25% of the population, so it's a lot of people, they will take 4 to 5 times longer to break down their adrenaline than somebody who has 2 copies of the VAL. So you might have a husband and wife, and the husband might be one and the wife the other, and the wife, let's make the wife the calm one, because sometimes we get labeled as women as being the not calm ones. But so let's say that she's calm, she metabolizes her adrenaline quickly, is able to speak in a soft voice, but the husband gets upset, and he has this adrenaline that hangs around for next an hour instead of 5 minutes. That's going to affect so many behavioral things. And that's why mental health is so much fun, because then when you understand that and you say, you know what, if you are having problems with your relationship, then maybe your husband needs some ashwagandha to stop that adrenaline from triggering cortisol release and keep him calm and not let that be a cycle, and that'll be fine. And so there's not good genes or bad genes. Because that same COMT gene actually is associated with people being high achievers because they have so much adrenaline they can focus. But let's understand how it impacts someone on a mental health level, and then go, if you want to address it, here's diet, here's lifestyle, here's supplements that can help you so that you don't feel that you're imprisoned by your genes. You feel empowered by them.
I think that's really the beauty of what you're offering the world, is that you really offer solutions, So, I mean, I've done the 23andMe and I've done a bunch of other genetic tests, but it's a little overwhelming. I mean, you get all this information, but it's not really actionable. So I have all this information sort of sitting on my desktop, and I don't really know how to use it. And I think what I love about what you guys do is that you really offer evidence-based, concrete, suggestions on how you can actually change or sort of, either upregulate or downregulate depending on what you need to do to be more stable and healthier, essentially.
Yes. And there is a downside of that. And I'll tell you the downside. So we do give much more information than the direct-to-consumer over-the-counter genomics reports. And the reason we can do that is we're what's called a clinical decision support tool, which means we can only sell to licensed healthcare providers because we're giving so much information that we don't want to arm and harm, but also we can't give medical advice to a consumer. We can give support to our colleagues as clinicians. And so the downside is, just to be realistic, so your listeners know, is that you do have to work with a trained physician. It could be an ND, naturopathic doctor, an MD, a DO, or we also other licensed healthcare providers of, nurse practitioners, PAs, chiropractors that have trained in functional medicine or neurological training. And so we have to have someone that we can train, but that also gives you a guide. And I do think that because the brain is so complex, it's really useful to have a guide. And you only need your genomics done once because your genes don't change. People will ask me, once I've gone and done this and I've made the changes, do we retest? And I'm like, no, we don't need to, because this is your roadmap. And then where you go, how we address it tells us if we're at the end point. Do we have success? But I have parents that have been on journeys with their children or for themselves for decades, and they're so appreciative because one parent and he's willing to even be interviewed if you ever want to interview a parent that's gone through this process. But he was telling me how his daughter had been staying home from school since she was in second grade. She had never gotten through a full year of school without homebound, would not get out of the car from school, had never joined a club, had never joined a team, never gone to parties. And they had spent huge amounts of money going from doctor to psychiatrist to everywhere trying to figure out the cause. And really part of why it wasn't able to be figured out without genomics is she's in the 4% of the population that was very low on an enzyme that you need to make serotonin and norepinephrine and dopamine and nitric oxide. And that enzyme is called tetrahydrobiopterin. It's sold as a prescription medicine, Kuvan, for people who have a specific PKU disease at a higher dose, but that's not something anybody would have ever tried for her. And then she had some oxytocin related things. And so you can take a lot of the mystery out of it. Now she's going to parties. She joined a team. She hasn't missed a day of school this year. And this is the first time, again, she's 13. It's the first time since second grade. And so I think that genomics is a big investment for some people because you do have to find a trained physician. So you're paying for the genomics and then you're paying for somebody, a clinician trained on it. But raising children is super expensive, or taking care of yourself. And there was a study that showed that 60% of the cost of depression is borne by the individual who has it because of lost wages, lost productivity, everything that goes on in their life that affects and just the happiness factor of the quality of life. So I think that it's important to realize that we're not all the same. So if you're feeling like you're not fitting into a box that your doctors have put you in and you're not getting the answers and understanding, that's why we made genomics. We wanted to change the future of medicine.
Which is just brilliant. And I mean, we're almost out of time, but there are a couple more questions, but I think I'll only ask you one because I don't want to take too much time. So, but this is a big one, but maybe you can condense it. We often you talked about the POP genes or the POP SNPs rather. What are the others? So there's COMT, we know there's MTHFR, there's also ApoE4. What would you say are sort of the top SNPs that you would look at for mental health? Or is that too much of a general annoying question in the sense that there's so many that it's very reductive to talk about the top 5 or something?
Well, I think that you can talk about the top 5 and that's great. But the problem with the top 5 is if you aren't in the top 5, you don't have an answer. And so the problem with them is the top popular ones tend to be ones that are in 20, 25% of the population or more. MTHFR is one of the most popular genes, but 2 copies of it are in 14% of the population, and 1 copy is in 45%. So it's a really important gene, but I would say that the problem with genomics at looking at the pop genes is you're going to miss the individuality. And that what we found is you really have to look at hundreds of gene variants in order to get enough of a map. And we're still at the beginning of genomics. I am sure a decade from now, the field will be able to map out so many more. But in order to get the answers you're looking for, I don't think just looking at the top will count. I mean, other popular ones that I think are important, like I said, I do think that HTR1A is important. But again, it's not just the gene, it's the particular variant. The variant that I was talking about that gives you 2.8 times the risk of depression and anxiety is RS6295. But to give you a map of all these genes, someone we have to sit in there going, okay, this gene variant and this gene variant and what to do and all that. And I think that that's the reason that anyone wanting to use genomics really does have to use a tool to map it out, because there's too many. But yeah, HTR1A is important. The thing is, there's also really important inflammation ones, like interleukin 1 beta is very important for the brain, IL-6, TNF alpha, BDNF, but those tend to be common. And sometimes the real answer, the people we help the most are the people that have 2 copies of a gene that's only in 1%, 2%, 5%, 7% of the population. And those aren't popular, but they're really important if it's you.
Yeah, totally. And so my final question, Sharon, is about you. And basically, how have you used this tool to help yourself, and how has it sort of changed your life? And obviously that's a very big question, but maybe just focus on a couple of points where it's really improved your health and your life and you action it.
Absolutely. So we didn't really talk about this particular gene, but TCN2 is a gene that is the carrier of B12 from the blood to the brain. And I happen to have 2 copies of it. And so my blood levels of B12 weren't particularly bad, but I eat a lot of plant-based food, so they weren't great either. They were like in the 300s. And when you have TCN2, you need to have much higher levels because you have to flood the system if your carriers aren't working to get it into the brain. So you do better if you have levels of 1,000 or 1,500. And I sort of stumbled upon that retrospectively, this one, but then it made sense in that I was, I'm sure a lot of people will resonate with this. You get samples of different things and you're kind of testing it out. And serifol and NAC, which is B12 and methylfolate and NAC, dropped off some samples. And I thought, well, that's kind of interesting. I'm just going to take it. That what's this big? I knew I had MTHFR, and I thought, oh, it has methylfolate, and I'll see. I wasn't having depression or anything like that, but let me just take this methylfolate and see if I feel better. But it was combined with NAC and B12, and it made a huge difference. Like my brain got faster. Wow. And so then about a year and a half later, 2 years later is when we started working on the genomics. And when I discovered the TCN2, I realized that the B12 was really the key ingredient there for me. So that's made a big difference. Not to reveal too much, but not unusual. I'm a double CompT. Remember how we said it's high achievers and people who can work long hours? Yeah. I can work very long hours because I make plenty of adrenaline. But for my friends and family and my business partner, knowing that and understanding that was really helpful, because now we joke that we don't go anywhere without ashwagandha. She will not share a car, let alone a hotel room with me without ashwagandha, because even as you can tell today, when my adrenaline, we get talking and I get excited, I make a lot of adrenaline, and I should have taken an extra ashwagandha this morning. but
is the flip side of that you then have a tendency towards anxiety?
And I think it didn't manifest classically for me because it wouldn't be all the time. I wouldn't wake up feeling that way. But if I had a lot going on at work, and so I didn't label it as anxiety, but it it definitely retrospectively is a form of it. And so ashwagandha has been a game changer for me. Um, Other things that I think that have been important for me, the brain inflammation type that I make is more the interleukin 1 alpha and TNF alpha. And so lion's mane mushroom has been really helpful to me. And I feel, so it's really that I'm not one of these people who wants to take 20 or 30 different things, but we all have the things in our family we want to protect ourselves against. And so the other thing that's really helped me, whether it be talking about osteoporosis or, protecting your brain from strokes and other things, I feel so much more empowered that I have a roadmap of what I can do to help protect my brain. Because just because you're a doctor doesn't mean you get a pass on family history. So heart disease, all of those. And so I feel like I've been able to come up with my own precision regimen that, fits into a small enough little pill box that doesn't overwhelm me. And that's what I try to do for my patients. Now, if they have something big going on, like they're having cognitive decline and they have an ApoE4 and a lot else going on, I don't promise them one small pill box. So I don't want people to think we can always get it tiny, but at least we can get the tightest protocol for each individual.
And you've seen good, amazing results. I mean, do you track your results? Do you measure, do you have this? I mean, you're a researcher. Do you actually track the sort of success of your treatments?
So we are trying to do that. You can't track every different disease category. So the way in research that we are encouraging, not only in our practice, but practices across the country, we first collect case reports so that GCH1 tetrahydrobiopterin, we're now getting all these great case reports. Then we'll do a publication about that. And then we'll try to do prospective trials where people can kind of register and get consent from the patient and track prospectively specific markers. So we're doing prospective trials, we meaning various IntellxDNA doctors, right now on cognitive decline, both the one that Dr. Bredesen is doing, they use our genomics as part of that trial, and Kat Taubes, who has been on your podcast, and I know many people know. And so we'll do it. And then we also have another trial just using genomics because Dr. Bredesen's registration trial, they have been blessed with, they've done a lot of work to come up with a huge protocol and get an expansive amount of information, but we're doing a smaller trial that is looking at just genomically targeted, and that's going well. The retrospective data from our office, just because I don't want to make people think that everyone's cognitive decline, for example, gets better, is it depends on the topic. So in autism, we're having tremendous success, meaning probably about 80% of children get some, significant to benefit. In cognitive decline, about 40% using genomically targeted medicine are getting significant improvement. Another 30% are getting a little bit of improvement and stabilizing. And then there are still some people that have not been able to improve their cognitive decline. And everything from compliance to mold to all kinds of stuff factors into that. But it really depends on what's going on. So I never want to promise that we're going to be able to fix somebody's depression, anxiety, cognitive decline, or autism. But I also feel like understanding root causes, even if it doesn't fix something, is still going to help. One of our doctors has now told us that even in someone with trisomy 21, a child with trisomy 21, which of course we can't get rid of that extra piece of chromosome that's in there, she's gotten significant improvements by addressing the other things that she could address. So I feel like it's a way of practicing medicine that most people, that the vast majority of people do benefit from, but we can't cure every disease, of course.
No, but I must say, I mean, it sounds to me as if every single person should benefit from this and, should go to their practitioner and make sure that they get these panels done, because there's absolutely no downside. It's more information. And it sounds to me as if it's the way of the future and that this is the way everything's going to go, I hope. because it's so much more precise and personalized than just giving people, drugs for their symptoms or whatever we do now.
Yes. No, I definitely think that the era of precision medicine is here, and that our work is one piece of it, and that hopefully scientists and physicians across the world and country, we will all build and share and contribute to the knowledge and expand this work. If your listeners do have a physician or clinician that is interested in learning, maybe they're already trained in integrative or functional medicine, but they say, I haven't yet offered this test. We do have a free mentoring and training program. One of the things, the mission of both myself and my co-founder is our goal, and we're both at that last third of our career, is to help train as many clinicians as possible, and to expand their knowledge base of precision medicine. And even if they only order one report on that one patient, they're still going to get our training. And so in our mentorship, we actually help them behind the scenes, mentoring them on their first 3 reports. And we have online training and then live training options and such. So even if their physician hasn't yet done it and they're going to be their physician's first patient, know that they're going to get great results because we make sure that our physicians get well trained and mentored, have that ability.
Which is amazing. And so to find you, Sharon, it's IntellxDNA, spelled INTELXX for you and your partner.
No, 2 L's. INTELLXX DNA, because it's an intelligent approach to DNA with 2 X's in the middle because of the 2 X chromosomes, since my co-founder and I are both women.
That is so cool. So IntellxDNA, and that's where everyone can find you. And I have to say, this has just been riveting and so fascinating. And this medicine of the future, which you represent, and just hats off for everything you've done and everything you stand for and you're continuing to do. And I think we're very lucky to have you in this world doing the work that you're doing, Sharon. So thank you.
That's so sweet of you. Thank you. It's my pleasure. And, again, I also am a big fan of yours and the work that you're doing, because everything that's happening in the science community and in the medicine community has to be translated to patients so that they can be their own advocates and know what the options are. And so thank you for helping them understand how they can untangle their own health mysteries and be on their health journey to optimal health.
Well, I'm so with you on that. I think that, a lot of patient education, doctor education, and hopefully we're getting towards this revolution in mental health that we all want to get to. So thank you, Sharon, and speak soon. Thank you so much for listening to the MindHealth 360 show. I hope that we've helped you realize that mental health symptoms have root causes that can and need to be addressed in order to sustainably heal, and have given you some ideas about steps you, your loved ones, or clients may take to start their healing journey. Please share this interview with anyone you think may find it helpful, and don't forget to subscribe to keep up to date with our latest interviews on integrative mental health. If you want further information, please go to www.mindhealth360.com or find us on social media. This information is for educational purposes only and is not intended to diagnose or treat any disease or to replace medical advice. Please always consult your healthcare practitioner before discontinuing any medication or implementing any changes in your diet, lifestyle, or supplement program.